Morning, Doug.
Good morning. How you doing, Connor?
Doing good. How about you?
Doing good. It's here. Do. So stupid. When did they start? I just sent a couple videos to my phone, or from my phone to my computer that I wanted to show you guys. And it's acting like I have to pay 99 cents to upgrade to something in order to even show them. When did that nonsense happen?
I had some trouble in my first engineering class. We had to like make videos of towers and stuff, and the size was the issue. I don't think it was like a subscription thing, but it was like really, really tough.
I made like really short 2-second videos, you know, they're like 14 megabytes. So it's like it shouldn't,
Oh yeah.
it should have went. It wasn't like a big long one. So I don't know. I'm trying to say if I'm gonna give up or not. Anyway. Cool. Well, it is awesome. You have reached the end of the week. And we are doing two things today, prepping for a test and looking at a project that I hope you'll enjoy. Let me see. Just with respect to, I just want to double check a couple things. With respect to due dates, you probably owe me homework today, right? Today's August 5th. Yeah, so you're giving me your homework today, which means I will post the solutions to that tomorrow. I'm writing myself a note right now. Post homework solutions. Last couple times I've been checking. I've actually checked kind of every question against the answer, so to speak. So at least I knew and could make a couple comments about, you know, but all I said was things like, go check my solutions for, you know, question 4.5, number 18 or whatever. But just make sure you do that before the test. And unfortunately, this time it's due today and the test is until Monday. So you sort of have time to just make sure you get your issues sorted out before it's too late. And then the other thing I was going to check is the project. Just make sure. Wednesday, the 4th. Was that due yesterday? That would make sense because we're starting one today. Yeah, so your project was due yesterday, so I'll grade that. Grade that today. And just in case this is you, you are welcome to work on, if you decide you want to, for whatever reason, you got another project and test and all that stuff. So probably the answer to this is no, but if you want to work on, just because I think it's one of the coolest things that we do in this class, if you want to work on the fixed support beam as an extra credit, you can still kind of do that later. But again, don't start it unless you finish it. Like, bug me until you see that it doesn't work. I was saying to one of you after class, or a few of you, it might have been Cheyenne, you can Google search that just like I did. I mean, I Google searched the simply supported beam and I got the equation 5WL to the 4th over 384 EI. Like, I found that. You can do the same thing for the fixed support so that you'll also know if you get the answer. If you get the answer to it right, if you get your equation right. Remember, your equation actually tells you the deflection at any point along the sort of the graph of the curve. Whereas the only thing that engineers care about is the middle of the curve, because that would be the maximum deflection. That would be the biggest spot. So you tend not to find the equation that you made so much, or it's harder to find. You can probably find that online too, but making that yourself is much more difficult.
So Doug, I thought the equation for the fixed support beam was the same as the simple
It is.
support beam.
Yeah,
So
the original equation, but the initial conditions are different, which produce a different equation. Not radically different, but since not only is y of 0, 0 and y of L equal to 0, not only is that the case, but y prime of 0 is also 0, because when it leaves the support, it's attached to the wall, therefore it's perfectly horizontal, and then it begins to kind of dip as it kind of heads away from there.
So that was like a big issue that
that'll create a different equation. So you'll start with the same one you started with before. In other words, what was it? WL. I mean, even after you took the integral, you take the integral 2 times, you can start right there. But then you just assign different initial conditions. But remember, you got to make all 4 of them work. Y of 0 has to be 0. Y of L has to be 0. That's a really kind of an interesting challenge in that problem.
I'll bug you about it later. I just remember thinking that there were too many initial conditions for how many variables we had. I was a little confused.
Yeah, you would think so, but there's not. It doesn't necessarily mean you have to. You sort of need every one of them, but they all have to be true. If you just use y of 0 equals 0 and then move on, you'll get it wrong, for instance. So in a sense, those are in order of difficulty. And again, if you get really inspired and want to take on the cantilever, you can as well, but I need to help you before you even start that one, because the equation you start with isn't even the same. The moment equation is totally different. So anyway, the most important part of your grade is, of course, are you tracking with all these concepts? And so the majority of today, I just want you to play with this to whatever extent you feel you need to. I just really want to give you time to work on the project. I'm going to introduce the other project. You can leave early. Do whatever the heck you want. But as usual, the answers, my complete solutions to this are already posted for you. So you may feel like I basically got this and I don't need to be here, and that's fine, disappear. But let's just stare for just a quick second at what we've learned in this section. This section we started with chapter 4, which was the beginning of second order differential equations. And so this first question, the second question, should feel pretty straightforward. But remember, why is there, you tell me maybe, why is 1 and 2 there? Is that like just 2 problems where you practice the exact same question? Why would I give 2 questions that are exactly the same? So you will have this note sheet, which needs a floor sweep. But the problem is it depends on the kind of answer you get. In other words, you might get 2 different real numbered answers when you write the auxiliary equation. You might get repeated answers, or you might even get complex answers. And if you do, you have a totally different sort of form that your solution takes. That's why there's 2 of them. So I'm sure I made one up that did one thing and one that did another. So, be aware of that. Stare at that note sheet so you have a really good sense of what's going on there. So they look the same, but their solutions may come out completely different as a result. Double check these. If you have time on the test, double check these when you're all finished, like graph. I guess I should be writing with a regular pen. Graph your, notice it doesn't say, is this y of x or y of t or whatever, it doesn't make any difference. But this time these are not springs. They're not, you're just throwing stuff in here. The spring constant will never be negative, for instance. It's just a random question to practice. But graph that y of x equation. Make sure it really goes through the point 0, 5. Make sure it looks like its slope at x equals 0 really is 3. Make sure, check it. Like, you should know something doesn't look right about this. And I should see a note, even if you got it wrong, that kind of says you understand that. Again, I'm giving more partial credit for I know that I don't know than I am for I don't know that I don't know. You have access to Desmos, and it doesn't take that long. You should be checking this stuff. And of course, like me, you should sort of expect you're going to make some dumb mistakes. And so be aware of that. I should have that open the whole time. And then of course, if you had time, you could check it manually, right? You could actually take your y of x and find y prime of x and y double prime of x and actually plug them back into this and actually see that you indeed get 0. That'd even be kind of cooler, but you can probably respect or understand the fact that if you graph it and it goes through 0, 5 and has a slope of 3 at 0, like that's kind of a good indication that it worked. So anyway, awesome. Then we moved into the next section where what's on the other side wasn't just 0. Notice I said wasn't just 0 because there is still a 0 there, which means these general solutions should include the homogeneous case as well. So you should look at my sheet to take your guess, like, oh, okay, this thing is supposed to be equal to e to the t sine of 2t. And so what's my guess going to be? Is it going to be a times e to the t sine of 2t? Is that what my guess is? And you should not make that guess wrong. That's why I'm giving you that note sheet. You should make that guess correctly because it's very time consuming on a test to not even know what to guess. I'm hoping we practice that enough that you know the right answer to that. But this is exactly what we did yesterday. It just doesn't have a practical application. But notice I said general because I did not give you these initial conditions. So up here, you're going to get a particular solution since I gave you an initial condition or a couple of them. But down here, general, just going to save some time. And I think we talked about cheating in Desmos to check that too. I'm suddenly remembering that, didn't we go back and say, if this was f of x right here, didn't we go back to Desmos? I'm suddenly remembering we checked this. Didn't we go back to Desmos and say, hey, what's f double prime of x plus, I'm looking at this top one, plus 3f of x minus 10 f of x or prime of x. And then we look to see, is that equal to 0? And Desmos will say, yeah, it is. And so we didn't even have to take the derivatives ourselves. We didn't even have to do them. So to the extent that you maybe don't feel comfortable checking that, make sure we talk about that today. So as we did yesterday, you should sort of have, one equation. I've been calling them Y1. Maybe that's your homogeneous case. So you do that one first, because remember the homogeneous case is kind of interesting in this sense that notice that's e to the 1t. In other words, r is equal to 1 right there, or I think it's r. Yeah, it's r. R is equal to 1 right there. And notice theta is equal to 2. And there was like, a possible danger, like your guess may not be what you think it is. It might have to be improved or modified a little bit. And it'd be nice to just do that from the start. So it's always good to kind of do the homogeneous case first, and then go back and do the case where, what's your y of, in this case, we know it's t, but maybe that's a e to the t sine of 2t. You should know that that's not the right guess. But your second one is, what produces the kind of non-homogeneous answer, or what I called the educated guess answer yesterday. So all of these have 2 different answers. Is this one any different? The answer is no. It's just equal to a polynomial instead of sines and e's. And it also doesn't have a y prime, but maybe that'll just make your life easier. But every one of these has got an auxiliary equation you got to start with. Being able to look at that and say, there's my auxiliary equation. Since it didn't have a y prime, then it doesn't have an r. And so when I solve that, I'll get values for r. And if they're imaginary, I do one thing. If they're real, I do something else. And I'm very much hoping that because this review is not just me saying, oh, let's give them a day to try to figure it out. It's more like you probably didn't understand it a day at a time when I was teaching it, but it probably feels a little overwhelming now that, we're kind of looking at the whole thing. And so the idea today is it's not just review, it's more to actually help your understanding join everything you did on individual days to where you see it as kind of one harmonious problem. Is question 5 terrifying? That feels kind of long for a test, but is that terrifying? Again, it's just another second order differential equation. And it's got everything. But it's not terrible thanks to these plus signs right here. And don't forget that one. You got to add that one yourself. There's actually 4 separate equations that are answers to this, and you add them all together. Does that concept make sense to you? Leaving this class. So I'll have one of my answers might be, a e to the 2t, and I'd solve for a to find out a is 7 or something like that. So there'll be one of those answers, and then t cubed, my second equation, since it's t cubed, then I'd have everything cubed on down. So that will be my t cubed answer, and then I've got a cosine of junk. And you should understand that cosine of junk not only gives you the cosine of junk, but also the sine of the same junk. And those could have their own coefficients in front of them. And so, again, I'm finding A and B. Again, though, those are not going to be general solutions. You're actually going to find A, B, C, and D for this one, and just A for that one, and A and B for this. We're actually going to find all of those. You're going to determine those coefficients. What makes it general? Actually, this one right here, the homogeneous case, that's the one that's going to have the 2 constants in it, and you're not going to be able to determine those. So that's where, again, you're going to look at this over here and say, oh, that's the auxiliary equation r squared plus r minus 6 equals 0. I'm going to solve that for r. And as soon as I know what r is, then I know my equation has got e to the rt's in it. And if it's got 2 real roots, 2 actual numerical roots, then I'll have 2 of those, like e to the 2t and e to the 5t or something like that. I'll put c1s and c2s in front of them. And so I'm going to have this really gigantic answer for this. It's just crazy that you could even solve something like that. And very important, number 6, you should not recognize. This was section 4.6, which in the interest of time we skipped. I can't remember if I stuck it on the syllabus. Yeah, I did. I stuck it on the syllabus for Tuesday next week because it's kind of neat and I want to show it to you, but I decided this is enough. Let's not put it on the test. So make sure you do not worry about that one. And then the last thing was, so really there's 5 questions there that are just random, irrelevant practice questions. And then this last one is spring related. Can you write your own equation and then solve it and actually find them? This time your y of t equation will actually be modeling the motion of a spring. And notice this is a nice one in the sense that I told you its weight, I told you its spring constant, and I told you its damping coefficient. So you know everything. You didn't have to work that hard to kind of figure that out. But notice I didn't just say find the equation. I did say find the equation, but I also said, can you use it for a couple of things? Can you use that equation now to answer a couple of interesting things?
So would that equation be equal to the force of gravity because it's hanging down from something?
Yeah, so here's an interesting thing. If you hung a spring, and notice I said it's hanging from a spring, so that kind of implies it's hanging straight down. And the spring used to be right here, kind of all coiled up. And then you put a weight on it, which caused it to hang down from there. So then it actually ended up kind of elongating and doing this. As long as you call that new location, as long as you call that new location 0, then your equation is still equal to 0, not equal to gravity. The only time you got to say it's equal to gravity is if you add the weight later. But if you put the weight on and let it reestablish its new point of equilibrium down below, and you say, okay, there it is, it's hanging, it doesn't really even matter how much weight's on it, then it's equal to 0 there. And then you either push it up a little bit and let go, or you pull it down a little bit and let go, and it starts bouncing. Then no problem. Then you just set it equal to 0 and go. Good question. So let's take I don't want to just jump immediately into the project and something else. Plus, I don't want you to feel overwhelmed. My advice for this is, if you look at that and say, yeah, those first 2 questions are pretty straightforward, I think I can get those, even though, I definitely need to practice, and I'll check those in the back. But, maybe you look at like question 5 and think, yeah, question 5, that's pretty big. If I could get that one right now, then I, feel pretty good. So maybe I'm not sure about 5, or maybe 7. Like, I don't know about that one. But my point is, as usual, this is not an assignment. I'm not grading this. So do none of them. Just go take the test if you want to, if you're crazy.
Is there going to be a problem on forced mechanical vibrations?
No, it'll be more like this.
Okay.
Where this isn't forced. That last one, number 7, based on Ben's question, is really a free mechanical vibration problem.
Yeah.
In a sense, question 3 was a forced mechanical vibration problem. So was question 4. It's just I didn't add the realism into it, so to speak. But no, I'm not gonna ask you a bunch of what I consider to be really cool, but I'm not gonna ask you questions about what's its steady state condition out there, and some of the questions that were asked in the assignment. I could, but again, I want the test to be pretty straightforward. Can you solve a second order differential equation and at least do the easier application of kind of a spring? I feel like if you can do that, you got the basics of what this class is about. So spend a little time, work on whatever of those you want. You're more than welcome to just say, hey, can you do number 5 or whatever one you want me to do? I'm more than happy just to start doing one of them too.
Could you do 5? That would be good.
Okay. Yeah, because sometimes it's a little nicer to see it done live than it is just to kind of look at my solutions. So if I get rid of some of this, do you agree with my guesses, which were sort of half-hearted and quick? Let's just look at them one at a time. Is this the proper educated guess for that chunk of the solution? And again, be looking at your note sheet, or I don't know, working on your memory, but you don't need to. You should be able to determine from your note sheet if that's the proper guess. So the danger with trig, with E, is if there's E to the 2t there, remember the danger is from your note sheet. Let's take a look right here. E, we have an E to the 2t. In other words, R is 2. That's what's sitting on the other side. And notice the good thing is this isn't here at all. That's just not there. It's like a constant 10 times e to the 2t. So I don't have to worry then about this portion of the guess, right? Because there is no polynomial. But what's the danger? If r, which is 2, is also a root of the auxiliary equation. In other words, if I solve that auxiliary equation as part of the homogeneous answer in 2, it happens to be one of those roots, then the fact that this happens to be e to the 2t is going to be a problem. Basically, my guess is correct unless I go back to this auxiliary part, which is what I should be doing first for that reason. That would be a problem. And so let's see, I can see that I can factor that. So that'd be r plus 3. So I feel like I'm just saving time. I don't have to put that in the quadratic formula. So I got r is -3 and r is 2. Uh-oh, that's exactly what I just described a second ago. That's an exact match. So if that had been an e to the 5t over there, no problem. My guess would have been a e to the 5t, but actually this is telling me a e to the 2t is not going to work. Now, just to show you that, let's do it really quick. Let's say you didn't notice that and you said, I think my guess for 10 e to the 2t is a e to the 2t. Watch what happens. You know how to do this. If y1 is a e to the 2t, then wouldn't y1's derivative be 2a e to the 2t? And wouldn't the derivative of that be another 2 multiplied out for a e to the 2t? So now I have all the ingredients, y double prime, which is 4 a e to the 2t plus y prime, which is 2a e to the 2t, and then minus 6y. Minus 6 and y was a e to the 2t, so minus 6a e to the 2t. And I need, is there some way that I can get that to be equal to what it needs to be equal to, which is this 10e to the 2t? What do you notice? Uh-oh, the computer just went black. I suppose it'll come back in just a second. What do you notice? Can you see my screen?
No, now we can.
Okay. What do you notice that is problematic about that when you go to try to get, notice everything is e to the 2t, but what do you notice when you try to collect all of those a's together to make them be 10?
It's 0.
It cancels out. You get no a equals 10, which means no matter what you pick for a, it's being multiplied by 0. So you can't get it to work. That's what happens. In other words, if you weren't smart and did the auxiliary equation first and already noticed that that guess wasn't going to work, then you would have got here. And because you're new at this, you probably would have thought you screwed up. When in reality, it's just that's why mathematicians said, well, how are we going to make a better guess for this? Now, what does the note sheet say to do if that's the case? If r is a root of the auxiliary equation, it is, what do you do?
Put a t out in front of the a and the e.
Yeah, notice it says make S1. And like, what the heck is S? S is right there. So it's basically saying, yeah, there's a t out in front of this. In other words, if you want this to work, you got to multiply your answer by t. So my point is we should have already known this. We should not have wasted the time since I gave you a note sheet. I mean, I don't think you'd know this if you were just left to yourself, but it basically means that should not have been our guess. Our guess should have been that y1 is equal to t a e to the 2t. Supposed to be an extra t out front. Now we're going to be able to find an answer to this thing. Before I finish that completely though, that's, since I called these things, you know, y1 was this one, y2 was this one, y3 was this one, I'll make the homogeneous answer So there's my homogeneous answer. And that informed me that my E to the answer wouldn't be correct. So let's go try to get that Y1. Well, again, you don't have any choice. You have to force the A to produce what you need it to produce. And so I've got to do what I did before, which is take the first and second derivatives. But what do I have to be very careful about when I take these derivatives now that I have a brand new guess? Well, the derivative taking is much more of a pain. Do you see the product rule now that is there thanks to that T? If you screw that up, it's also not going to work. So the derivative of AT is A times E to the 2T left alone plus the AT left alone times the derivative of E to the 2T, which is E to the 2T times 2. And so that's fun. And then Y double prime. So I take the derivative of this, not product rule. So that's just 2E to the 2T. That's not so bad. Plus, and again, I'm seeing product rule here. I'm thinking of the multiplication sign being right there. So I'm thinking, what is the derivative of 2AT? It's 2A times the E to the 2T left alone plus the 2AT left alone times the derivative of E to the 2T times 2, which turns that 2 into a 4, as you know. So now I think I have everything, and I can go back, thanks to the plus signs, plug all of that mess into this and just pay attention to this part of it and try to find an A value that will produce 10e to the 2t. Now, again, it's a little weird because don't we have an answer that's te to the 2t? Isn't that kind of weird? Like there's no t over there. That's not 10te to the 2t. So it sort of feels like this guess that we made somehow is going to be weird or not going to work. That seems kind of strange. But let's go plug it all back in. So fortunately, the y double prime didn't need to get multiplied by anything. So I can just copy that down and say that was added to y prime, which also doesn't need anything multiplied by it. So that'll maybe make less dumb mistakes. It's very exciting. So there's y double prime. There's y prime. And then it was minus 6y, was it? Minus 6y. So minus 6 and y was a t e to the 2t. And I, hopefully, big old question mark here, I need to somehow get that to work. So you should be thinking like terms. In other words, adjunct together, that is the same. Well, here's some e to the 2t's. That's not what I wanted. Undo. Here's some e to the 2t's. Here's some more e to the 2t's. The next one's got a t in it. I don't want that one. There's some more e to the 2t's. And that's it. That's all the e to the 2t's. The rest of them are t e to the 2t's. So what do I have there? I've got two of them, 2e to the 2t's, plus 2a e to the 2t's, plus another a e to the 2t. So all of this is e to the 2t, and I need that to give me the 10 e to the 2t. So notice that's now doable. Stuff didn't cancel out. So I end up with 3a plus 2 has got to be equal to 10. Is that 2 supposed to be a 2 or is it supposed to be a 2a? There's something bugging me there. It is 2a, isn't it? There's supposed to be an a there.
Yeah.
A. 2. No, it's not supposed to be a 2. It's supposed to be an a, isn't it? Again, I love making mistakes like this in front of you because I think that's the kind of thing that should give you pause. In other words, this was my guess, right? So then I said, hey, product rule. Just checking to see if I did this right. So the product rule says derivative of AT, which is A, times e to the 2t left alone, plus the derivative of a e to the 2t. Yeah, there is an a there. There's supposed to be an a there. And the only reason I caught that is just because I've done this enough that's like, I don't remember there ever being constants here. It seemed like there were always a's in them. So it's really 5a equals 10. And again, I've said this to you before, but that's a pretty honest mistake. Can you tell from what I wrote? Can you tell that this person knows what they're doing? Yes, you can. So they got it wrong. All right, I'm your grader. What do? I spend hours. I look at this. Okay, why did they get it wrong? I see that they understand the product rule because they did it right a whole bunch of places, and yet they spazzed out and lost that A. What am I going to do? I'm gonna go back here, and I'm going to go dude on your test. And then I'm going to see if everything else you did is right, and I'll write something like that's your only mistake. And, then I can still give you 7 out of the 8 points or whatever. I can still give you most of the points, even though you got it wrong. And I might take off 0 points if you at the bottom of this say something is wrong with my answer, but I don't know what, I couldn't find it. Because now not only did you get it wrong, you even know you got it wrong and you just didn't have time to fix it. I might take off nothing if you do both of those things. I got lucky though, caught my mistake, right? Is that my only mistake? I don't know. Could have more. So I think A is 2. So that means I now have Y1, and I think the answer to that is now 2e to the 2t. So there's kind of my second answer. There's my first. That's the first part of it, that homogeneous answer. And now I have the answer that takes care of the 10e to the 2t. Then I move to the polynomial portion. Is this y2 the proper guess for that? The answer is tentatively yes. Again, the only thing that's in my mind is, does that also need to be multiplied by an extra t somehow? So it becomes at to the 4th plus bt cubed plus ct squared plus dt.
I think a t to the, just a t needs to be multiplied by everything.
So let me reason this with you out loud. Notice that answer is 18 t cubed times e to the 0t, as far as your note sheet's concerned. Because e to the 0t is 1. So our R value, if you will, is 0. Does that match the R values that we got here? The answer is no this time, therefore I don't need to add a t. Now that's kind of tricky, right? Because there's no R value there, like there is no E. But had one of these over here been R to the 0, if it was like R to the 0 and R equals 5, and those were the two answers, the fact that there had been a match there, that would have caused me a problem. But it didn't, so that means my guess is okay. How do you get a cubed equation? You take the derivative of a cubed equation. So by pattern then, notice it doesn't really hurt anything that I'm reusing the same letters, although if that bothers you for some reason, go ahead. Call them C1, C2, C3, C4, C5, C6. Use all the letters of the alphabet, I don't care. But in order to plug this back in, the pattern we've seen is we've got to take the derivative. And notice this derivative is much nicer than last time. I'm so happy. That's a much nicer derivative. There's no product rules. It's not E. It's not chain rules. Just good old power rule, the easiest form possible. When I take the second derivative, I'm going to get 6at plus 2b. And now I can just plug that all back into my original equation and see if I can get that. See if I can find an a, b, and a c, and a d that force it to give me 18t cubed. And notice this polynomial only had a cubed term, but had it had a little bit more, like if this had, if this didn't just say plus 18t cubed, then said plus 5t, does it make sense? You would not have had to find a fifth equation here. You could have taken care of 18t cubed plus 5t all at one time. Do you understand that logic? If you did them separately, would that hurt anything? No, wouldn't. But the answer I'm looking for on this side is just 18t cubed, which I guess means 18t cubed plus no t squareds, plus no t's, and plus no constants. Okay. So I have y double prime plus y prime, and then minus 6y, minus 6y. So minus 6 times everything.
Those should be 12s, right? Or, I mean, 36s.
Yes. Am I okay? Yeah, so I said minus 6 times everything. Those are 6's, not b's. We good?
Oh, okay, yeah.
And so I plugged it all back in, and I'm only paying attention to the polynomial. And so I need this to be equal to 18t cubed, right? So I've got 4 unknowns and only 1 equation. That should strike you as impossible. I have 4 unknowns to solve, and yet I only have 1 equation. But why can you proceed with this?
Usually one of the unknowns cancel out.
Notice I need 18t cubed, and there's only 1 term up here that's cubed. Does that make sense? Therefore, the only way this is working is if a is -3. -3 times -6 is -18. So I know right now a has to be equal to 3. At least I think so. You know, of course, I could have made some dumb math mistake. Probably did, right? But then I look at my, and it doesn't matter what order you go in, but next thing I'm looking at is my t squared terms. And so I see that I have some there and I have some here. And so I say, okay, well, that means 3a minus 6b has to be equal to, well, again, notice what's on the other side, 0t squared. It's actually harder that there's nothing there, if that makes sense. It'd have been better if there was a 7t squared over there, because then you would have known to set this equal to 7. But there isn't any of those. So I need that to be equal to 0, which would be impossible except for I just got done figuring out what a was, right? So that means 9 has got to be equal to 6b, which means I get b is equal to, I think, 3/2. So now I found that answer. So let's keep going.
Real quick, is A not negative? You have the minus 6a equals 18.
Yeah, it is negative. I said it was negative, but I didn't do it, did I? And that's exactly what I'm talking about. So I've made my second dumb mistake. So that's my point, is like you're going to do that on the test. So yeah, that was supposed to be negative. That makes that -9. Then I actually get -3/2. In my case, if I'm alone, I'm going to catch this because I'm going to graph it and it's not going to work. Thanks for pointing that out, just to save us all some trouble. So then I look at the t terms. There's one there, there's one there. Notice I'm careful to include the sign that goes along with the t. So I see that 6at plus 2bt minus 6ct all has to be equal to 0t. So those are all the t terms. Again, that would be impossible, except for I know a is -3 and I know b is -3/2. So then I'm going to be able to find c. So what do I get? 18 on the other side. I get -3. Don't trust myself. So I get negative. I better write it out. -3. So I get -3, I think. Feels like something's wrong here. -6/2, which is -3, minus 6c equals 0. So I get -6c equals 21. And so c would be 21/6, which is divisible by 3. So I get 7/2, I think, except negative. And then lastly, the constants. So I've got one there, one there, one there. Just have 3 constants. It's easy to miss one, so I'm just double checking to make sure I didn't miss anything. It's one of the reasons I kind of like to circle everything instead of just stare at it, because I know that I've already looked at all the ones that were, circled. So now I can say, okay, my constants, I got 2b plus c minus 6d. It's bugging me there's no b term. I'm suddenly, wondering if I did, or a term. And again, there's no constant on the other side. So all that's got to add up to 0, which again would be impossible, except for I know that b is equal to -3/2. And I just figured out that c was -7/2. Yeah, this last one was supposed to be 6d, not c. So that means if I add 6d to the other side and I end up with -3 minus -6/2 minus 7/2 is, I think, -13/2. I'm going too fast. Divide by 6. I think I got d is equal to -13/12. But I'm very unsure of myself, when I say that. Like I think I'm done. But again, let's go test this really quick just to remind you of this. I'm gonna stop sharing that. I'm gonna test just this portion of it because I'm very unsure. And this is where I would have caught my mistake, as I said before. So let's see, I don't exactly remember how to do this myself, but I'm thinking that now that I have a, b, c, d, I'm thinking that f of x is equal to, since a was -3 x cubed, when I'm putting it all back in, right? And then b was -3/2, so minus, I'm gonna type 1 point, now I'll just type -3/2. And that was x squared and minus 7/2 x, and then I got d is -13/12. So again, I kind of hope I got this wrong. So I'm thinking that's the answer. But remember, there's nothing I can check with this. But what I'm really interested in now is, to see is f double prime of x plus f of x, because this is what the original equation said, minus 6 f of x. I'm really interested to see, what is that supposed to be equal to?
18t cubed.
Yeah, 18t or 18x cubed. And so here's what I'm going to do instead. The way I'm going to check this is by just looking at the 2 graphs. In other words, if I say y equals this graph, now notice that's a little encouraging because that actually looks like a cubed equation, doesn't it? And then I'm going to check and see what is y equals 18x cubed. And now I know, bam, they're exactly the same. Cool. So I'm right. I got to fix that time. Do you agree they wouldn't have looked the same if I had been left to myself? Cheyenne didn't bail me out and tell me I wrote 3 down wrong. Then I would have saw they weren't the same graph, and then I could have, it would have taken me 20 minutes or whatever, but I could have found it. Test taking strategy, though, that might cost me 15 minutes to find that mistake. You might be better off to, go on and at least get the whole test done and then go back and kind of test some of these things out. But now I know I don't need to check. I'm gonna brag on my test and just say I know this is right, even if you need to grade it. But the point is that didn't take very long. That's kind of what I'm getting across. You're crazy not to check these. And I actually don't make a lot of dumb math mistakes. Relative to most people, I actually don't make that many dumb math mistakes. And yet you've watched me make a couple of them now. So that means I confidently know, I guess I'll take the time to quickly rewrite this. Yeah, we are using T's, not X's. And then my final one, and you could probably see that I can't really, I mean, if I gave a question like this is probably an hour-long question. And so if I do, I can't give very many questions, but you can also see that this covers a ton. This covers like everything we've studied. It's like one question. So the last one then is this cosine of 3t. Is my guess correct over here? Is that the right guess for that? Can't read my own writing. If there's a trig expression, do I need both of them like this?
I think that's good.
The answer is yes, you do. If your non-homogeneous form is equal to the cosine of some junk, notice down here, you need a cosine plus a sine. You need the whole thing. And notice our cosine doesn't have the polynomial in front of it, t to the m, so that means it doesn't need all of this junk. Oops, I'm sorry, wrong spot. Doesn't need all of this junk right here. I won't look at this right now, but there is the danger that I would need to be multiplying my guess by t, but it basically doesn't have an e and it doesn't have trig. So that means I don't need this. I'm sorry, it doesn't have an e, it doesn't have a polynomial. So I don't really need any of this business. All I really need is the coefficient. And by the way, I'm being a little flippant about the note sheet, but this coefficient right here, that's the coefficient that I was guessing. I said A and B. That is left behind, even though there's, m is 0 for us. It's at to the 0 power. Like even if that's at to the 0 power, there's still a constant in front of this. So the note sheet's, not as, it's clear in the sense that it solves all problems, but it's actually kind of hard to use when you're, when your problem is really simple. Like all I have here is just cosine of 3t. In one sense, it might be better to have a note sheet that was like 3 pages long. So you just had, what do I do if it's only cosine? So my guess is right. A cosine of 3t, B cosine of 3t, or sine of 3t. And I know this is going to work. I know this, I won't be wasting my time. So my third and final equation is A equals cosine of 3t, was 3t, wasn't it? B sine of 3t. And again, I'm happy to see that I don't have the product rule. I do have the chain rule. So when I go get my derivatives, the derivative of cosine of junk is negative sine of junk times the derivative of the junk. The derivative of 3t is 3. So there's a negative 3 out in front of that. The derivative of sine of junk is cosine of junk times the derivative of the junk. So the 3 gets multiplied by the b. So there's my first derivative. Second derivative. Again, not any worse. Just do the same thing. The derivative of sine of junk is cosine of junk times the derivative of the junk. So that means there'd be another 3 out there. Derivative of cosine of junk is negative sine of junk times the derivative of the junk. So the 3b out there gets multiplied by another 3. Now, I just need one of these, and minus 6 of these. And I need that to all add up to 1 cosine of 3t plus no sine of 3t's. So I could live dangerously and kind of try to put this all together just from what I'm looking at right now. Or I could write the whole thing out. Maybe because this is a test, I don't want to live dangerously, so I'll just write the whole thing out. And I'm going to try to write small. So I'm writing y double prime now. Negative 9a cosine of 3t minus 9b sine of 3t. And then I don't have to multiply this by anything either. So minus 3a sine of 3t plus 3b cosine of 3t. But then this is multiplied by negative 6 when I get to that. So that'd be negative 6 times a cosine of 3t minus 6b sine of 3t. And all of that needs to be equal to this. So then I say, okay, well, I need 1 cosine of 3t. Where's my cosine of 3t's? There's one, like terms. There's one, there's one. Cool. What are my coefficients? Negative 9a for that one, plus 3b for this one, minus 6a for that one. And I don't need those to match the coefficient in front of cosine of 3t, which is 1. So this is not as easy as last time because I have 2 unknowns here, so I can't figure that out. But at least I can collect the like terms together. So I can say 15a plus 3b equals 1. And so there's my first equation. And I guess I'm going to get a second equation, aren't I, for the sine equation? So then I look at my sines and I say, okay, I've got there. Yeah, that takes care of all of them. I didn't miss any. What do I have? I've got negative sine, negative 9b for this one. I got negative 3a for that one, negative 6b for this one, and that equals no sine 3t's. So if I collect the like terms, I get negative 15b minus 3a. And so I've got 2 equations, 2 unknowns. And then I'll be able to find an a and a b. And that kind of verifies that my guess was right. Nothing canceled out. And I won't even be lazy. I'll do this by hand. So I'm rewriting the blue equation, minus 15b equals 0. And I could add these and get rid of something by just taking, let's take this one times 5, because then I would have 15b and negative 15b, which would be nothing. 5 times 1 is 5, 5 plus 0 is 5. And then I'd have negative 75 a's, and 3 more would be negative 78 a's. So apparently a is equal to negative 5 over 78. But again, I'm not very confident of that. I'm thinking, wow, that's a crazy fraction. You know, why didn't the teacher make this up to work out nicer? Maybe they did and I got it wrong. Maybe they didn't and it's perfectly fine. I don't know. I don't see that I made any mistakes. I tried to go slow, but I'm not sure. I'm not confident. Again, this is a good argument to stick it in the matrix because notice, although that wasn't terrible, now I find myself going, well, God, A is so ugly now. I don't really want to plug it back in. I mean, I find myself thinking, well, I guess I could plug it in here, but it's kind of like, what an ugly mess. I guess I have to continue though. Negative 15b minus 3a, that'd be minus a minus, that'd be plus 15 over 78. That's got to be equal to 0. So that would be add 15b to the other side. So we end up with 15 over 78. If I divide by 15, I guess those cancel and we get 1 over 78. So I think b is 1 over 78. So I'm hypothesizing that y3 then, since a is negative 5 over 78, my original guess said a was in front of the cosine, so that's negative 5 over 78 cosine of 3t plus 1 over 78 sine of 3t. So I'm proposing that that is the answer, but again, I'm very unsure. So let's check this one more time. Negative 5 divided by 78 cosine of 3. I'm going to say x, so I don't have to call this, I don't have to change the way this is worded. Plus 1 divided by 78. It's the sine of 3x. And so there's my graph of my answer. There's what my answer looks like. And I'm hoping this is actually equal to, well, what it's supposed to be equal to, which was, I forgot, 1. It's supposed to be equal to the cosine of 3x. Maybe you're smart enough to stare at this and you can just tell that that's either true or not true. Graph tells me, yeah, it's identical. They're right on top of each other. So I guess it was right. How long did that take? 45 seconds. Type that in. So of course, I'm sharing the screen with you, but of course, since the answer was, there were 4 different answers to it. Again, don't forget the 0. Now I'm just going to say the general answer is all of those added together. Does that make sense? And I could check them all at once if I wanted to. Like I was checking these one at a time in Desmos. I could have just typed the whole mess in all at one time. That'd be kind of fun. Of course, I'm going to get some really crazy graph when I do that. My computer is not wanting to share. But I think this time, in the interest of time, I will not do that. So one of the things I'm worried about on the test is just the fact that, do you recognize that this particular question, the fact that they were separated here by plus signs was really important, because that allowed me to do them. And that was what your book called in 4.5, the principle of superposition. Like we just superimposed these all on top of each other. I got to find them all separately. Whereas if the other side had been equal to, say, 15 and it had an e to the 2t and a t cubed, then I would have a totally different guess. I can't do those separately. I've got to do them all at once. Now maybe my guess is a for 15, and then I still have an e to the 2t, but then I'm going to have an a, or I guess I have to do letter bt cubed and bt ct squared and so forth. Like when it's multiplied, I definitely have to notice that I can't do those separately. So I'm very happy when I see plus signs. That's the idea. How's your brain? Is that okay? You find yourself going, I think I can do this? Or is it more like, yeah, I'm going to die. This isn't going to work.
Feeling good.
It's not hard. It's actually mostly algebra. I mean, there's obviously all kinds of silly things you can do wrong algebraically. And, like I said, one of those problems we had the product rule, and I would have had to catch 2 of my own mistakes without your input. So burn some paper, because I'm a human being. I will tire if your work is either not legible or you're like, I'm going to save paper and squeeze this all into a really tiny space. I do spend 6 hours grading. There's only like 14 of you. It takes me literally 6 hours because I spend a half an hour trying to find all the mistakes on, each of your tests. But I will get tired if I look at your work and I can't read it and I can't follow where you went. Waste some paper and kind of go in order. Do things like I did. Call them Y1, Y2, Y3. Draw some kind of a separation. Maybe even label the start of that. It's like, use different colored pencils, whatever. It's like, this is my Y2 equation, a bunch of work there. Like, help me, because I'm not watching you do this. You're watching me do this, so my work can actually be uglier, but I don't get to watch you do it. So I'm going to have to look at what you leave me. So this problem is going to take like 2 pages, right? Well, use 2 pages, grab some more paper if I don't give you enough space.
Hey Doug, do we need much time to go over project 3?
Yeah, that's what I was just thinking about right now. I think I'll introduce that to you now. I'll tell you the things I'm thinking. Is number one, I don't want to overwhelm you. Like, okay, you're all reviewed for the test, right? Let's move on. I don't want that. I want you to enjoy the projects and not be murdered by them and not feel like, I got a test now, I got to do this stupid project. So part of me is thinking I might give you Tuesday to work on that project instead of teaching you that extra topic. That kind of feels like that might be nice. So anyway, these are all just things I'm thinking about. Off the top of my head, I'd say I'm leaning toward that. So we're taking the test Monday. The test Monday will be as per usual. I'll post it so that it opens up at 8 in the morning. And I'll give you, I think, 2.5 hours to take that test anytime you want to start it. But I do want you to start and finish it, all at once. So you can take that at your leisure, and then I'll obviously grade it as fast as I can after that.
Is that going to be like the last test where it's like 2 hours, but like due ultimately by midnight?
Yeah.
Okay.
Yeah, you can start it. You could start it at 9:30 at night if you wanted to, and then you'll still be able to get it done before the day's over.
Nice.
Cool.
Okay.
Yeah. So I'll probably continue that. I think that's nice freedom that I can extend to you. So yeah, let's take a look at this project for just a few minutes here. I've got to drag it up for you to see it. I don't think I already have it up here. So, main goal of this project is to try to do something to see if you can actually find a model of something that actually is vibrating, oscillating, whatever you want to call it. And I have 2 pictures here of something I tried a few years ago. I went to the hardware store and I bought a spring. It was cheap. It was like $1.50 or something. It was pretty cheap. And then I just hung a weight off the bottom of it, in this case, a tape measure. And of course, when you let it go, it's going to, bounce up and down and eventually come to a stop, right? And so that's oscillation. Can you tell what that other picture is? Probably not. That other picture is like a stick. It's a piece of wood that I found, and then I just put a weight on the end of it. What did I have nearby? My shoe, because I was riding my bike to school at that point. Back when we used to go to school, remember those days? And of course, with that shoe hanging on it, you can see that it bent the stick down, right? Notice it's a fairly small stick. And so, you need something kind of small so that you can affect it without, having a huge weight. I don't have to put 8 tons on a bridge to get the bridge to vibrate. I can just put a shoe on the end of that stick. And of course, notice now it found its equilibrium. It's at 0 right now. But of course, if I pull the shoe down a little bit, it's going to start vibrating to a stop. And so the idea is could you come up with an equation that would kind of model the motion of that? I mean, that's the end of it. Now, I want you to understand, do you need to be successful at this to get an A? The answer is no. Like, you just need to give it a whirl and then tell me about and again, I would far prefer, I guess I'm not going to make you, but I would far prefer you do this with 2 other people, like get together, like meet another human. I just want to know about your kind of trials and so forth as to kind of how this actually goes for you. And if it doesn't model it at all, but you can kind of, you can see why it didn't work, then great. Now I do have some hints on here. So problem, find a model for something that vibrates freely to a stop. I do want to say one other thing, because this is something that was kind of bugging me before, and I think I have some thoughts on this, but this is really open-ended. So for instance, let me see, I can turn this and show this to you. So here's my light right over here, right? See this? The little pull chain that's on there. So, that's a pendulum. does it make sense what's causing this to move is actually gravity? Whereas the two examples I just showed you, the spring is what's causing the motion and the stick is what's causing the motion. If you want to try like a kid on a swing set, I got no problem with that. However, I'm a little concerned just that it's because it's gravity here. Will that be the same? And again, if you try that, because you think, well, lots of things move like that, you know, in the air, like there's a power line out there and the wind blows and it does the same thing. And so, you know, will this model it? And the answer could be, yeah, or maybe it doesn't work. I know there's some equations around pendulums. And so that's something I feel like I could look up online, but you know, could I model it? I don't know. And I also have some suggestions that go beyond this sheet because every year I'm always trying to think about how to kind of do this better. So my original goal with this project was this, and I guess probably the easiest way to visualize this is kind of with this tape measure over here. In other words, if I knew the weight of it, now would you agree that's a problem? I mean, we don't have access to if you don't have access to a scale, then how are you going to know how much that thing weighs? But, you know, if you think of the equation for the spring, one of the things you needed to know was the mass of whatever it was you were hanging. Well, I got to weigh that thing, right? So, you know, maybe you have access to a scale. And so that'll be great. You might, if it's like a bathroom scale, but, you know, what you're weighing may not be very heavy. And so that'll be, again, a part of the error. Do I care if your weight's actually wrong? You have a lousy scale and you can't measure very accurately, and you know, so therefore your model's wrong. But, you know, I actually don't. It'd be nice, but you know, we don't have access to the physics stuff, and so we just have to do what we can. One creative thing I did notice, though, if you want to be a little more mathematical, I went to the cupboard and I found a bag of rice that weighed 454 grams, but I didn't want to tie that to the spring, although you could tie that to the spring. But then I put it on a balance beam, if you will. I took that same beam that was on my shoe, and the tape measure was hanging over here, and the bag of rice, the weight of which I knew was over there. And then I moved it until it balanced. And then because torque is force times lever arm distance, I knew this weight times this distance, weight 1 times, should be using a different color. And use this weight times this distance would be equal to this weight times that distance. And so I sort of came up with a fakey way of seeing what my tape measure weighed. But again, that's probably not going to be super accurate. Does the bag of rice actually weigh 454 grams just because that says that on the side of the package? No. That's actually what they're promising on the side of the package, which means it probably weighs quite a bit more. And so there's problems with this, and that's okay, I guess, is what I just want to make sure you understand. So there's one of my hints. I showed you this yesterday, but the spring constant, if you actually use the spring, can be calculated using the formula. And this is what I showed you yesterday, Ky equals mg. That is Hooke's law. Now, one of you pointed that out yesterday. Once we realized it wasn't moving anymore, that means the y prime and the y double prime went out of our cool equation, and you know, then you're able to actually find K. You can actually figure K out from the spring. And so I know M and I know K, but how am I going to get B? This is really cool. Well, the damping coefficient is related to the period. And so it can actually be calculated. Maybe you recognize that part of the quadratic formula over there. That's the chunk of the quadratic formula. It's the right side of it. Remember, that's where the theta came from. Remember, there was an alpha for an E. And remember, because this is vibrating to a stop, all of you should be using the underdamped case. And the underdamped case had an imaginary number in it. That's what's kind of interesting about this. If it's going to wobble back and forth, it's underdamped. And so you can actually take a stab at that. Now, there's one thing on here that's just, and because I've tried this at home and so forth, the time is utterly critical. So theta can be found with 2 pi over the period. Well, does it make sense if you swing this back and forth, if I swing this back and forth and I hold it here and it's like start the timer, stop the timer, you know, how long does that take? 0.151 seconds. You know, start, stop, no, 0.53 seconds. If you get that time wrong, it really screws up your model. It's got to be really accurate. And that's hard to do because I'm assuming you're just going to be using a, you know, your phone timer or something like that. But I did give you a suggestion that will help. Don't count one period. Don't just go over and back. Remember, the periods are the same. So do it 20 times because it makes sense. That'll make your error 20 times less. So I said, count it 20 times, 20 periods, and then divide by 20 and you'll know the period. And then even then I said, do that a few times. Because actually, if you want this to actually work, then you need the time correct to the 1,000th of a second. Like, or this isn't going to work very well. So you can go, oh, that's 1.2 seconds. That's not going to work. It's got to be really accurate for your model to actually be accurate. If you try the spring thing, like I was just describing, actually, you can kind of expect it's not going to work that great. And B will be the problem. The damping coefficient will be the reason that it didn't work. The other problem that you'll have is, and this is what I said here in red, it will make your quest much easier if the spring, and it doesn't have to be a spring, if it oscillates to a stop inside 45 seconds. Now, watch this little thing over here. Does that come to a stop in 45 seconds? Well, if it takes really long for it to come to a stop, that just makes it even harder to model because it just means the tiniest things make a difference. Now, I have some suggestions of something I'm going to try this year that's different. I guess I'm going to have to try to show you these videos just straight off my phone because I was telling somebody before class, I took a couple phone videos, I emailed them to myself, but then when I can't open them, it's like, I don't know. It's probably 'cause I'm old, but so here's an interesting, geez, how am I going to do this? Here's an interesting suggestion. So what I did is I found a piece of metal. In my case, it was like part of a square, a drywall square in my garage. And then I put a tape measure behind it. And just like the stick, and there's nothing on the stick. I didn't put a shoe on the stick. I just put the piece of metal there and I pinned it to the, I pinched it onto something so that I could grab it and it would wobble back and forth. But I put a tape measure behind it so that I could see where it started and stopped. And this video I'm going to show you now, I filmed it in slow motion so that I could actually see where it stopped. Your phones now have the ability to film stuff in slow motion. Again, I am 100%, you should understand that like this is still janky. Like that's not going to work great. And we need physics equipment that starts and stops stuff accurate and we can get perfect measurements and all that kind of stuff to get it to work perfectly. As long as you kind of play with the idea of modeling something, you'll get it. Like just because we don't have all the equipment, who cares? I have one idea now that I'm going to try out that I'm really stoked about, and I think it's going to work awesome. Actually, watch this one. What am I doing? So here's the same thing, but I put some weight on it. Now, again, that's in slow motion. That's slow motion camera. But the thing I want you to see in this is watch how can you tell that it's like not slowing down? Look how it like goes back to almost the same exact spot it went before. This is going to be really hard to model because it's not stopping in 45 seconds. Remember how when we saw them damped a while ago? The thing is there some way, and I'll show you this in a second, but is there some way that I could get it to be more damped? In other words, come to a stop. Remember how the examples that we did in class were stopping inside like 45 seconds, something like that, or like 12 seconds even. What's going on here? Share. What we really need is for it to damp quite a bit faster in order for this to really work well. In other words, what you just saw a second ago is damped because it's not gonna go forever. But would you agree it actually looks something more like this? Like if I pulled it away, say 0.4 meters, then it went down, and where did it come back to? Like 0.39. Does that make sense? Can you appreciate that's not what I want? What I really would love to do is find something that started at 4 and then it came back and it was already at like 0.2. Does that make sense? You feel that's much more damped. And then when it came back, it was like, so after like 10 seconds, it's already kind of coming to a stop. It's just, you're going to have a much more realistic number for B for that. And it'll be much easier for you to actually kind of take measurements. But if it wobbles back and forth and it's like going to the same exact spot on the tape measure every time, it's going to be really hard for me to tell, what's going on. And that's kind of the idea. So let me show you my last attempt that I think is going to be awesome. So I took the same piece of metal, except I was thinking, how do I get it to damp? And my idea was, what if I put a clipboard on the end of it so that it goes through the wind? Now that's again slow motion, but that thing is slowing down really fast now. That's kind of the idea, because of the fact that it's pushing its way through the wind now. So it actually damped it. So the wind resistance caused it to slow down a lot. That's kind of the idea. So a stick with something like a sail on the end of it so that it's flying through the air. That's what I'm going to try. That's what I'm going to try this year, see if I can model it. Now, just some other quick thoughts. The thing I didn't like about that is notice I don't have a spring anymore, and notice it's kind of sideways. It's like, what am I weighing now? Like there's no weight on the end of it anymore. So I'll tell you what I'm going to try to do, and I would actually suggest you try this too. What I'm going to try to do is collect data and say, okay, at time 0, it was at this distance. And then, and I pulled it back, I pulled it out a certain distance, and I see the tape measure on the wall behind it, or I hold the tape measure. So I'm out there at 5 inches or whatever measurement I want. And then I let it go. And it goes over to the other side and comes back, and it's going to come back way short this time. So the two things I need to know is how long did that just take and where did it come back to? So let's say I had it out here at 5 and then at 1.2 seconds, then it came back, but it only came back to say 3.5. Really quite a bit shorter. Does that make sense? I'm hoping that by choosing the right sail, I can really get that to happen. So that means it kind of did this. Does that make sense? Now, do you understand that the period has now been established? Now, am I going to be able to measure the time from over to back? No, I'm going to let it swing a whole bunch of times. I'm going to let it swing 20 times and divide by 20. And that's going to be my period. So I established my period at 1.2 seconds. Now, as I said before, is that accurate enough? No, it should be something like 1.237. Like play around with that so you really get the period accurate. But now that that's the case, in a sense, I know that the next one is going to do this. So I actually know the period. And if I know, because I took measurements, what these locations are, I'll call that 2.1 or something like that. Because I have a few of those measurements right there, here's what I'm wondering is, can I circumvent the process entirely? Yesterday, I showed you this equation. I showed you that the equation with both sine and cosine, this is on your note sheet, was equal to a e to the alpha t sine of theta t plus or minus phi, if I remember right. Like that's your model. And I showed you yesterday that this chunk of it right here was a perfect match to this E graph, right? Dang it. Computer just went to sleep again. So I know that I can find that number as a result of knowing the period. I know I can figure that number out. And could I do with these ordered pairs, and maybe I have 4 or 5 of them, could I do regression? And I want to show you how to do that in Desmos in a second. Could I do regression and actually discover, if you will, this entire chunk of the equation right there? It seems like maybe I could do this without a mass. And in my case, because it was waving back and forth and it wasn't a spring, I'm not sure mass is even a part of it. Really what I want you to do is just play. I don't want you to spend more than like a couple of hours on this. If you spend more than 2 hours, you're doing more than you should be doing. I don't want this to be a huge 6-hour project and it takes all weekend. No, you're doing it wrong. I'm grading these really mercifully. You've already seen that. 2 hours tops. Play with this concept. If you put a little time into it, play with it, regardless if you're, draw your conclusions. Tell me it worked great. Tell me it worked terrible. But don't, if it worked terrible, don't see that as like, oh, now I got to do it again for another 2 hours and start all over. Because this is not going to work well with crappy physics equipment. But I think it will teach you something. That's why I think it's still worth doing. And I think it's actually a little bit of an advantage because we're not using too much technology. I'm really hopeful actually that my little wind resistance thing is actually going to make it measurable, and that I'm actually going to be able to do it. Now it kind of bothers me a little bit that I'm not predicting everything. I'm not measuring weight and damping coefficient. Like notice I don't even know what the damping coefficient of that piece of metal is, the internal workings of the metal. I don't even know how I would measure that. Maybe there is some way. But it seems like I would have to have like a scale and push on it, right? Like I'd have to have some way of measuring its resistance to pushing. And again, off the top of my head, I don't know what that would be. So there's part of me that kind of bothers me about this, but this feels more doable. And as I warned you, a regular spring doesn't work very well. It's just way too hard. B is it's too tiny of a number, and it's got to be ridiculously accurate for it to actually work. Okay, so let me show you just one other introductory thing. Just going to leave it at that for now. Let's see what's wrong with this. And because I used T, I got to go back and put a T in. And so I have 3 coefficients, that capital A, the little a, and the capital T. So I notice this actually wobbled out of control. So what makes it not wobble out of control is choosing a small e value. So I'm going to type 1 point. And notice my A is 1 right now. I wonder what difference that makes. And then my T, which is the period. You see how T is changing the period of this graph? And then that thing that's missing is, notice it wants to go through 0, 0. But if I throw in, say, a +2 here or something like that, you see how now it starts at a reasonable location? So it's like, I'm just trying to see, can I get that to actually model? So, notice that has a location, it's 0.56, and then that returned to 3.17, and that returned to 1.943, and this returned to 1.189. Does it make sense? I might be able to take, maybe not that accurate with the stupid camera and a tape measure against the wall or something, but could I take measurements to determine what those links were? Now notice in my case, I know the equation up here, at least I guessed it, I just made one up, but notice my A is 5 and my A is negative 0.125. But if you take measurements, you're only going to kind of know this. Do you understand that? You're going to maybe have these measurements right here, but you don't have the equation for this, and you're trying to find it. So what I'd like to show you is how to use Desmos to actually do regression, because your graphing calculator won't do it. You have to be able to, the form of the answer, and the cool thing about Desmos is you can put that in there. So notice, can you see that the period for this is 3.61? Actually, it's not 3.61. I thought it was 3.61 because that said 3.61. How do I find the period of this? Of these ordered pairs, if you will? Somebody tell us.
Peak to peak, subtract the two.
Exactly. What am I subtracting, the X or the Y?
X.
X. Good job. So I got 3.927, which is accurate to the thousandth place. The reason I thought it was 3.61 is I said, oh, look, it starts at 0, but notice that's not the peak. The peak is actually over there to the left. So I should be able to take 15.391 minus 11.464. I got 3.927. And then I should be able to take 11.464 minus 7.537. So I have the period. Does that make sense? And the period isn't theta, but the period allows you to figure out theta. But what I'm wondering is, if I have just these 1, 2, 3, I'm just going to use these ordered pairs right here, could I do regression to find that E equation? That's what I'd just like to show you. I'm going to forget all of those. I'm going to take a picture of them and then I'll show you. If you've never seen how to do regression in Desmos, it's really awesome. Why would I not want to use this point over here?
Not the
Why don't I
peak.
want to use 0, 4.546? Or at least I'm worried that I shouldn't use it. Well,
The point looks fine, Doug. I think we should keep using it.
my concern is, isn't the E going to follow the peaks of these all the way down? You know what I'm saying?
Yeah, I was just messing with you. I was concerned about that too.
So actually, I think instead I'm going to actually use these 4 points and just not even use that first one at all. Since in a sense it's back in time, so maybe I'll use those. Again, I haven't done this yet. I'm just kind of thinking out loud.
So my question was, if you pulled it back, wouldn't that actually be your peak? So this graph actually wouldn't be real applicable.
Yeah, I mean, that's exactly part of the problem here. Because as I said, I'm kind of playing around with this and I'm not 100% sure. So, but it has to do with the starting amount, right? Yeah, I think I see where you're going with this. In other words, if this wasn't a 2, but was a 0, or let's see, what if I made another letter out of this? B. Put it, like if I pulled it and let it go, does it make sense that would be the peak? If I pull it and I give it some speed, then what you're not going to do, because you have no way of measuring that speed. But if I pulled it out to 5 and then I just let go, then wouldn't that be the peak? Do you agree with me?
Yeah.
That's probably what's going to happen. That's kind of my point. So maybe it is the peak. And if it is the peak, and then the peak is right there, the graph isn't shifted, and then maybe I don't have to worry about that. But in my case, I'll just stick with what I was doing before, just because all I really want to do is show you Desmos. Let's see. So here's how Desmos works. You've got to go in and stick in your data. So actually, I guess I don't have to go. Let's see, which one was it? I think it's this one, add an item. And what you add is a table. This is where you put all your numbers in. So from what I had up there a second ago, that's one thing I don't like about Desmos, by the way. If I go here and I click on that point, and I go click over here, it goes away. It'd be so cool if I could just kind of like leave it there, but it won't let me somehow. So that was at 3.61. Oops, what just happened? I was in the wrong world. I probably won't put all of this data in just because there's no reason for me to put it all in. Just enough to kind of help you see the concept. So 3.61, 3.174. So that was kind of my first ordered pair. And my second one was 7.537 and 1.943. Notice that's damping really quickly like that. Unlike what I showed you a second ago, it's started at 3.1 and then it, after one period, it was already back to 1.9. That's not what you just saw. It was like wobbling back to the same exact spot every time. That's why the damping, if you can get there to be more damping, then it'll be way easier to measure and the model will actually potentially work. I'm going to just put one more point in, 11.464. 1.189. So here's how regression works in Desmos. It's so amazing because if you, and you should have done regression in your graphing calculator, you have like 5 choices and you have no control over it. In Desmos, you have total control. You can say any equation you want. I could say, I'd like the equation to be, and watch what I type here, not y equals, but y tilde, a little hoop-de-doo that's over in the top left-hand corner of your keyboard. It's right above the tab. You don't say y equals, you say y, whatever that symbol is, tilde, T-I-L-D-E, I think. And then you say what your equation is, and you say, okay, well, I think that's a sine wave, you might say, and you're wrong. So you might say, I think that's t, or let's see, x. Notice it's x's and y's up there, x times a, and then I think it's a sine wave. And then you say, okay, well, then I'm also going to put a letter in front of B and another letter in front of C. Now, why didn't it work? Because that says X1 and Y1, not X and Y. So I have to go back and put a 1 here for Y and a 1 there for X. 1 there for X, and then it suddenly worked. Notice it was terrible. Is that a good model? No. Why? Because you chose a terrible model. That's not a sine wave. Now, what is the model? We said, or I already told you, it's an E equation. So I'm going to go back and type in a totally different model. So it's some coefficient, I'm calling it A, times E raised to the another coefficient that I don't know, and then times X, and again 1. Now I'm very disappointed. Like, notice that's terrible. This is not what I was expecting at all. I thought I was going to get like an E graph up here that went through those, and this is utterly terrible. So I don't know why. I'm going to try throwing in not just that, but maybe I'll try throwing in a third. No, it's not. That's up there.
Oh, I think I know why. The A that you put down is being used from the A previously in the equation.
You're exactly right. I bet you that is the reason. So I've used B and C. So I haven't used C and I haven't used D. Let's try that. Whew, thank you, man. So that's a good thing to discover. It was reusing the same letters up above as it was for sine a minute ago. Notice that's a really good map. And notice it tells me what C and D are. It says, yep, there you go. Look at C, 4.984. Look at D, negative 0.125. Hey, what were they a minute ago? Wasn't A 5 and D 0.125? Like, do you see how good of a job it did at finding the equation? Because you're not going to know it, right? You don't know the equation. But it found it, didn't it? So I'm just wondering if I know the period and I now know the E part of that equation, if I could actually manufacture the equation that modeled that. Actually, it doesn't seem like it would be that hard, but it's going to take me time to kind of set that all up and take measurements. And all I really want is like your conclusions. Set it up, take a picture of it, take a picture of your setup, kind of look at, what I did on my sheet when I introduced it to you. And then just kind of tell me, yeah, if I had a little bit of physics equipment, this would have been better. The other thing you can do that's kind of fun, I think, is, like what if it doesn't work perfectly? Remember, you can make sliders for your equation up here and slide it, like you can slide it to perfection. And then, or you can just sit here and start typing your values. One of the things that kind of bothers me about this approach, which is kind of cheating because I sort of just took data and then I know now, thanks to this class, what these equations look like. I didn't know that before this class. I know that it's e to the junk times sine to the junk. I didn't know that before this class. Now I know. What would be kind of fun is, could I reverse engineer to find the damping coefficient, which is a combination of the wind resistance of the piece of paper, the clipboard I put up there, and then also just the nature of the metal. Is there some way I could work backwards and say, hey, this is the solution to the original second order differential equation, which had an M, a B, and a K in it. So I could almost these are just questions I'm asking off the top of my head. That's why I'm saying I just want you to play with this and see what you can come up with. I'm not going to grade it hard. So I am leaning heavily toward giving you Tuesday. I'll show up to class, but I'll probably just be sitting here working on stuff, and you either won't show up at all because you don't need me, or you'll just pop in and say, hey, you got any suggestions for this?
That'd be really cool.
Something like that. But I want you to have enough time that this is fun and not a bummer, not just one more thing you have to do. That's why I'm kind of thinking I should give you Tuesday. Math is awesome. If you're not having fun, you're doing it wrong. All right. Okay, I think I'll